Hello everyone. In this video we will prepare our exam for the MAT 241 calculus course, and we will discuss that topic wise. So the first topic is first type would be find out the center and radius of a sphere centered at some given point with radius r. So the formula for this one, the equation of the sphere centered at this point with radius r is of this form: x minus x naught square plus y minus y naught square plus z minus z naught square is equals to r square. So now in the problem they're asking you to find out the center of the sphere and radius of the sphere, and the sphere is given of this form: 3x square plus 3y square plus 3z square plus 2y minus 2z is equals to 9. So what we have to do is we have to transform this into this format. And how do we do that? By completing square. So what do we have is x terms, we have y terms, and we have z terms. So the first thing you have to do is to make remove the coefficients from the square terms. So you have x square, y square, and z square. The coefficient, we have to remove the coefficient. How do we remove the coefficient? Is by dividing each term by 3. So this gives us x square plus y square plus z square plus 2y 1 over 3. We can write this as minus 2 z 1 over 3, and that becomes 3. Now you have to remove, you have to make the complete square. So x is the only term is x square. There is no other x, so we can, this is our complete whole square. For y, we have y square, and there is another term here, 2 times y and 1 over 3. So you have to complete this square, which is not a square. And then we have one more term is z, which is z square minus 2 times z and 1 over 3. This is not square. So x is completely a square. We can see that x naught, there is no x naught here, so it means x naught is 0. We have to make this one in this format. So how do we do that? Is by completing square. So I will do this separately to make it like this, do this separately to make it like this, or you can just put it here. So you can just do it straight away over here. So that is x whole square. The completing square is that you take the square of the first one. So our first is y square, then 2 times the first, which we already have, is y, and the second is 1 over 3. So what is the extra term? What would be the second term to make it a square? So y squared, so we should have some term here, number. So according to the formula is a plus b whole square is the square of the first plus 2 times first, which is a, second, and the square of the second. So this term is missing now. So we have here this term is given, this term is given, the square of the second term is missing. So we will add the square of this term, right? And similarly, if we add it on the left side, you have to add the same thing on the right side. So three plus 1 over 9. So this is 1 over 3. The square of 1 over 3 is 1 over 9. The same thing goes with the z now, but the z is now a square with a negative. So if you have a minus b whole square, then the square of the first one minus 2 times first into second, and then the square of the second one. So we have here the square of the first one minus 2. We have the first one, we have the second one, and the square of the second one is again missing. So we can add this up from our side, and then the same thing we add on the other side of the equation. So 1 over 3 square is 1 over 9, right? Now you can write this down. So that would be the square of x. That would be the square of a square plus b square. A plus b. Here a is y and b is 1 over 3. Plus that is a minus b whole square. Here a is z and b is 1 over 3. And then you can take the LCM of that one. So you can see that the LCM is 9. So that is 1 plus 3 3s are 9 plus 1. So that gives us 11 by 9. So now we found this one, we found this one and this one, but we haven't got the r square. So we can write down this and take its square. So the square will cancel the square root. Again, we get the same thing. So we can write this equation, this number, in this format, which means our r is now this inside term. So now you have x naught here is 0. So x naught is 0. There is no x naught. Y naught should be y minus 1 over 3. So you can write this as minus 1 over 3 whole square. So the next term is minus 1 over 3 y naught, and the z naught is already minus over here, so that is 1 over 3, and your r is square root 11 over 9. So I hope if any such question is asked, that to find the center and the radius of a sphere and the equation of sphere is given, then you would be able to transform that equation into this format and then find out x naught, y naught, z naught, which would be the center of the sphere, and r would be the radius of that sphere. Okay, the second topic is finding the angle between two planes. So if we look at, this is a particular example. So if you have two planes and making an angle with each other. So this is, if you call this plane 2, this is plane 1, and you can see that these planes are making an angle theta with each other. Now, the same angle, this angle would be the same by the normal. If the normal of plane 1 and the normal of plane 2, if we take any one point on both the planes, right, and then find out the normals of these two planes, so n1 and n2, then it would be the same angle which is between the two planes and the same angle that is between their normals. So usually what you have to use is that you find out the normals of the planes, so n1 dot n2, and find out their dot product, which is by definition the magnitude of n1, the magnitude of n2 into cos theta. And you can write this down by cos theta is equals to n1 dot n2 divided by their magnitudes. And if you want to find out the theta, then you take the cos inverse on both sides. So one is cancelled with this one, and theta would be cos inverse of that one. So this is general example, general method. So whatever planes you are given, you have to use this methodology and you can solve the problem. So we are given two planes, plane 1 and plane 2. You can call any of these as plane 1 and the other plane 2. So the normal for plane 1, since normal is a vector, so you can write this down in the vector form notation, which is this one. So what is a normal of a plane? So let's go to the normal of a plane. So if you have a plane of this type, ax plus by plus cz is equals to d. If you are given a plane which is of this type, then the coefficient of x, coefficient of y, and coefficient of z makes the normal. So the normal of this plane would be a comma b comma c. Now we have to find out the normal of this plane and this plane. So if I call the first one as n1, then the normal of the first plane would be 3 comma minus 6 comma minus 2. And similarly, the normal of the second plane would be 2, 1, and minus 2. So now you have to find out their dot product, n1 dot n2, and the dot product. What do we do in the dot product is we just multiply the corresponding entries and add them. So 3 into 2 plus minus 6 into 1 plus minus 2 into minus 2. So that gives us 6, that gives us minus 6, and that's minus minus plus 4. So the dot product n1 dot n2 is 4. So now we have to find out the magnitude of n1, which is the square of each entry, and add them up and take a square root. So the square root of 3, which is 9, plus the square of 6, which is 36, plus the square of 2 minus 2, which is 4. So that gives us square root of 49, and the square root of 49 is 7. So the modulus of n1 is 7. Now we have to find out the same for n2, the square of the first entry 2, which is 4, plus the square of the second entry 1, which is 1, plus the square of minus 2, which is again 4. So that gives us 9, and the square root of 9 is 3. So we have n1 dot n2 and their magnitudes, and we can find out theta. The formula, if you write all this down, you don't need to write down the formula again. You can straight away write down theta. Theta is equal to cos inverse of that. But if you haven't written all these things, especially if you haven't written these, then you can write down that cos theta is equal to n1 dot n2 divided by the magnitude of n1 and the magnitude of n2. And then you can take out the theta from this one. So your theta would be cos inverse. And now you can write down n1 dot n2 was 4. And the n1 magnitude is 7. And the n2 magnitude is 3. And with the calculator you can find out the the cos inverse of 4 over 21, and that is approximately 79 degrees. So the third part is find out the parametric equations and the symmetric equations of a line that passes through some particular point and is parallel to a vector v. So the general form is if you are given a point P and the line passes through this point and is parallel to some general vector v, which is ai plus bj plus ck, then the vector equation of the line, or the equation in vector form, is given by the vector notation x, y, z is equals to the initial values from which point the line passes, x naught, y naught, z naught, plus t times t is any parameter vector v, or this is sometimes also called as r naught. So the initial vector, or the initial point from where it passes through, and tv. Right. So if you want to write down the parametric equation, it means you have to write down the x. So the x values over there, here is x naught, plus what is the x value of v. From this v, we have the x value is only a, so that becomes 80. Similarly for y, if you write down y is equal to y naught plus t, but from v you have to write down the part of y, which means j, unit vector, so that is b, and similarly for z you have to write down t. So if you're asked to find out the parametric equations, what you have to do is you need to know the point and the vector that is parallel to, then you write down in this format, and from there you can transform it into this, or you can straight away write down from these two in this order. So we are given the point from where it passes and the vector. So we know the formula x naught. So from here you can write down what is your x naught, y naught, and z naught. You can see that is -2, 0, and 4. And the vector, from vector you can see your a, b, and c values are 2, 4, and -2. So now you can just substitute these values in these equations and you will find out the parametric equation is x naught is -2 plus a is 2t. Similarly for y would be y naught, which is 0, plus b is 40. So you can write down only 40, you don't need to write down 0. And for z we have 4 plus, so there is -2, so that is -2 times t. So these are the parametric equations for a line that passes through this point and is parallel to the vector 2i plus 4j minus 2k. Now to find out the symmetric equations, you can write down x is -2 plus 2. You have to find out t values from all the equations and then put them equal. So from here you can say that if you want to leave t, you bring 2 to the other side and then divide both sides by 2. So you have t is equals to x plus 2 divided by 2 from the first equation. From the second, we know that y is equals to 40. So if we divide both sides by 4, we have that y over 4 is t. And from the third equation, z is equals to 4 minus 2t. So if I take 2t to this side and z to that side, so I would have 2t is equals to 4 minus z, and now divide both sides by 2. So we get t is equals to 4 minus z divided by 2. Now they're all the same t values, and the t values, if this is t, this is t, and this is t, then they are all equal. So if I write t is equals to t is equals to t, then you can write down their values, and these are all called symmetric equations. So if you are given any question of this type, you should be able to solve them. Okay, the next topic is to finding the equation of a plane that passes through some point, this one, and is perpendicular to some vector, this. So the general format is a times x minus x naught plus b times y minus y naught plus c times z minus z naught is equals to 0. So this is the general notation, or the general equation, or the general formula for the equation of a plane. And now you can find out this point and this vector. Once you have these two, you can find out the equation of the plane. So the question is, find out the equation of a plane that passes through this point 1, 2, and 5, which means your x naught is 1, your y naught is 2, and your z naught is 5, and is perpendicular to the line. They haven't given you a vector now, they have given you a line. So the vector, right, from this line, what is the vector that we know from this line is the normal vector, right? And the normal vector from this line, or the v that we can find from this line, is we just did the parametric equations where x was x naught plus at, y was y naught plus bt, and z was z naught plus ct, and we wrote this thing which was our v. So v was our vector a, b, and c. So we can find out v from here now using this thing, right? So we know that our x naught, y naught, and z naught are 1, 2, and 5, right? And our vector v is, the first entry is the coefficient of t in x, which is 1. In the second entry is the coefficient of t in y, which is 3, and the third one is in z. So we have now x naught, y naught, z naught. We have a, b, and c, which is our a, b, and c in that format. So we will just put the values now. Our a is 1, x minus x naught is 1, plus b is 3, y minus y naught is 2, and c is 4, z minus, and z naught is 5, and that is equals to 0. We have to just open it up. Multiply 1 into x is x, 1 plus 3y minus 6, 4z minus 20 is equals to 0. So we have minus 1, minus 6, minus 20 gives us minus 27. So if I write x, 3y plus 4z, and if you add them up, they gives us minus 27. And if I take it to the other side, this becomes plus 27. So this is the equation of the plane that passes through this line and is perpendicular to the given line, which is in parametric form. In this topic, there's different other topics included. So they're asking you to find out the volume of a parallelogram. We know that a parallelogram is, you have the two sides are parallel. So you on this side and this side are parallel, and this are parallel. So you just take one point here, whatever the vectors are you're given. So from that point, you take one vector and you take the other vector, and then you find out the cross product of that vector, and the volume would be the magnitude of the cross product of those two vectors. So it includes the cross product. What is the cross product? So you need to find out the cross product first. So if you are given these two vectors, the cross product is, you write down I unit vector, j unit vector, k unit vector, right? And then the first vector u. So the first entry, the second entry, and the third entry. The second vector, first entry, second entry, and third entry. Now find out the determinant of these two. So I as it is, we have to find the determinant of this one. What is the determinant? Determinant is you multiply these two and then subtract the multiplication of these two from it. So multiply 2 and 3 gives us 6 minus, then you have to subtract the multiplication of these two. So the multiplication of these two is 0. Then the next entry would be minus, and then we're checking now this row, so we will exclude this one and this one. So you have this line and this line only, this line and this one. So you multiply this and this. So 3 times 1 is 3, minus 2 times minus 1 gives us plus 2. Then plus k. Now we have to ignore this line and we choose these two columns. So 0 into 1 is 0, minus 2 into 2 gives us minus 4. When that minus multiplied to this minus, this becomes plus 4. So this gives us 6i. 3 minus 2 gives us 1. So 1 times minus j is minus j, and that is plus 4k. So this is our u cross v. Now we need to find out the magnitude of this one to find out the volume. Volume says that it's the magnitude of u cross v. And what do we do in the magnitude is taking the square of each component and add them. So we have 6 minus 1 and 4. So the square of 6 is 36, the square of 1 is 1, and the square of 4 is 16. And if you add them up, that is 3, and that is 4, 5, 53. So that gives us square root 53. In the same topic, if you can look at this one, and they're asking you to find out the volume of sorry, this was not the volume of a parallelogram. A parallelogram cannot have a volume of this type. So it is the area. So the area of a parallelogram is of this type. So the solution that we got was not actually the volume, but was the area. The volume is of a parallelepiped or parallelepiped, you can say it. So the question was to find out the area of a parallelogram, and this is the formula of it that we already saw of it. So now they can ask you to find out the area of a triangle. So triangle, and you're given one vector u and the other v, and they're asking you to find out the area of a triangle. So there are no such formula that we can use. So what we have to do is we have to draw a parallelogram. So you make a parallelogram, you find out the area of the whole parallelogram and divide that by 2. So once we find out the area of the parallelogram, you divide by this way or by this way, either this way or this way. It's up to you. Which means if I put the area into half, this becomes the area of a triangle. So if you're asked to find out the area of a parallelogram or the area of a triangle, you should be able to solve it with this method. So if you're asked to find out the volume of a parallelopiped or parallelepiped, then the general formula is u dot v cross w, or you can use either of the vectors first. You can write down u dot v cross w, or v dot u cross w, or w dot v cross u, right? So you write down the first vector 1 2 minus 1, you write down the second vector minus 2 3 0, you write down the third vector 7 0 minus 4, and you write down, you find out the determinant of this one. So usually you can find a determinant with either a row or with a column, but we choose the one which has zeros. So if you don't want to choose that one, that's okay. So if I choose it row 1 with respect to row 1, then we choose this one, and then we have to ignore this row and this column and find out the determinant of these two columns. So minus 4 times 3 is minus 12, minus 0 times 0 is 0. Again, we write down a negative, we choose the second in the row, the second term, which is 2. Now we will ignore this column and this whole row, so you are left with this and this. So you multiply this to this, gives us plus 8, minus 0 into 7 gives us 0. Then plus, here is already a minus, so that becomes minus 1. And now we ignore this column and this row, so you have to multiply here. 0 into minus 2 gives us 0. Minus 7 into 3 gives us 21. Right, so that gives us